We know that calculating whole powers of 10 is straightforward mental math. 10 to the power of 2 is 100, but calculating the exact power of 10 needed to produce a number like 21.58, the human brain cannot calculate that specific decimal exponent on its own. That is where the logarithm table comes in. Pull out a physical copy or open a digital one on your screen right now, because we are going to use it. Every logarithm value is constructed by snapping two distinct pieces together. The first is the integer half, called the characteristic. The second is the decimal half, called the mantissa. Once you learn how to independently find and merge these two halves, you can determine the precise fractional power of 10 for any positive number. Finding the characteristic requires shifting a number into standard form. That means you move the decimal point until there is exactly one non-zero digit sitting to its left. For numbers greater than 1, like 431.5, the decimal hops 2 spaces to the left. To keep the value the same, we multiply it by 10 to the positive power of 2. Look at that exponent on the 10. That positive 2 is our characteristic. We do the reverse for numbers less than 1. For 0.0074, the decimal hops 3 spaces to the right to clear the zeros, giving us 7.4 times 10 to the negative third power. Since logarithm tables are printed using only positive decimals, we need a way to combine our negative characteristic with a positive mantissa. We do this by placing a bar over the characteristic, which shows that only the integer part of the exponent is negative. The physical position of the decimal point in the original number completely dictates the integer half of your final log value. With the characteristic isolated, we can move to the table. The log table requires exactly 4 significant digits to work. To format your number, you temporarily ignore the decimal point entirely. If your number has fewer than 4 significant digits, like 0.005, you ignore the decimal and leading zeros. Then, pad the end with trailing zeros until you have 4 digits. This gives us 5,000. If a number has more than 4 digits, like 25795, look at the 5th digit. Because it is a 5, we round the 4th digit up. The final 4-digit sequence is 2580. These 4 digits act as exact geographic coordinates. In the next step, we will use them to navigate the rows and columns of the log table. Let's extract the mantissa for the target number 21.58. First, drop the decimal to get 2158. Now split it into a 211 grouping to navigate the 3 distinct zones of the table. Step 1. Use the first 2 digits, 21, and scan down the far left column to find the correct row. Step 2. Use the third digit, 5. Move horizontally across row 21 to intersect with the main column labeled 5. Extract that value, 3324. Step 3. Use the final 4th digit, 8. Continue further right along row 21 into the mean difference section and stop at column 8. Extract that value, 16. Finally, add the main table value and the mean difference value together. 3,324 plus 16 equals 3,340. Because the mantissa is strictly the decimal half of the logarithm, we place a decimal point in front of this new number to get 0.3340. This resulting decimal value represents the highly specific fractional component of our exponent. Calculating the final logarithm is simply a matter of merging the characteristic and the mantissa side by side. For 21.58, we assemble the final value by merging the positive integer 1 and the decimal 0.3340. The log of 21.58 is 1.3340. For our negative characteristic example, 0.0074, we do the exact same thing, maintaining the bar notation to get bar 3.8692. These assembled numbers are the precise mathematical exponents required to raise the base of 10 to our exact target numbers. Here is a chart showing the complete workflow. Starting numbers are converted into standard form to extract the characteristic. Then, 4-digit codes are used to pull the mantissa from the log table. Remember the lookup convention. We keep the mantissa positive so it matches the values printed in the tables. This is why we use bar notation. It separates the negative integer from the positive decimal. You now possess the mechanical steps to bypass the limits of mental math and accurately calculate fractional powers of 10 on your own. Now it is time to prove it. Grab your table and calculate the log of 347.5. Post both your 4-digit mantissa and your final log value in the comments below.